Hey, ladies and gentlemen, this is Erisa Wante once again to give you some online lectures. I'm teaching you probability, and in our first lesson, we introduced probability last time. So today we're going to continue looking at probability, and what we want to talk about basically is the complementary event of an event. We are still dealing with the sample space S and an event A of the sample space, just a single event of the sample space. So we said last time that we can represent the sample space and an event by using Venn diagrams. Okay, if you have a Venn diagram, then this rectangle is representing the sample space S, and an event is a subset of the sample space. This is A. Now, outside the A, okay, is what we call the complementary event A complement. Now, what do we want to talk about here? We know that the number of A is the event, plus the number of A complement is equal to number of the sample space. Okay, here we have to understand what we mean by the event we are talking about. We're using an example last time. If S is a sample space, okay, where a die is thrown and then you get the possible faces turning up, it could be 1, 2, 3, 4, 5, or 6, because any ordinary die has 6 faces. So if you throw a die once, any of those faces stands equal probability of turning up. Okay, and the sample space is a set of all of possible outcomes. Now the event A could be defined as okay, the score obtained is a factor of 6. Okay, and here the factors of 6 are 1, 2, 3, and 6. So the complementary event we're discussing today, okay, the outside of A, okay, what is not in A is when you check here, it is 4 and 5. Those are the elements which don't belong to A. So the complement of an event is a subset of the sample space that contains elements which are not in the event A. Okay, so we denote it by A complement, and if you get number of A here plus number of A complement, you get the number of the sample space. Now to get probabilities, we divide through by number of the sample space. Number of A divided by number of S plus number of A complement divided by number of S will be equal to number of S divided by number of S. Okay, and the number of A divided by number of S is the probability of A. Okay, plus probability of A complement. This is equal to 1. Okay, this result is so useful in probability. Okay, it is a result relating to complementary events. The probability of an event plus the probability of its complement sums to 1. Okay, and if I take this example here, which I've given you about a die which is thrown, and then you look at the faces turning up, and then your interest is to see factors of 6, then the probability of A, okay, there are 4 elements, okay, out of 6. This is 4 over 6. Then the probability of A complement, there are 2 elements out of 6. If you get probability of A and add to probability of A complement, okay, you end up with the 4 over 6 plus 2 over 6, which is equal to 1. So 2 complementary events, okay, an event and its complement, rather, to put it right, an event and its complement must, their probabilities must sum to 1. So this result is so important in probability. It is a result relating to complementary events. All right, we are trying to understand what an event is and what its complement is. Okay, and we begin by noting that Sometimes we use a complement with a bar on top of it to mean the complementary event. Okay, so when you find this, it means the same as that. Okay, and in this example, we begin with very simple examples, and before you solve anything, make sure you understand what we're trying to do. Now, this says the possibility space consists of integers from 1 to 20. So what we do first is to look at the possibility space. We said we use S to stand for the possibility space or sample space. Now list the integers from 1 to 20. 1, 2, 3, 4, 5, 6, 16, 17, 18, 19, and 20, because the question says it consists of integers from 1 to 20 inclusive, meaning that 20 is a part of. Okay, so they are defining two events here. There is an event A. Remember, an event is a subset of the sample space. So here, looking at these numbers, they are defining A to be, okay, an event, the number is a multiple of 3. Okay, so let's look at the multiples of 3. How do we get multiples of 3? They are obtained by multiplying 3 with the positive integers. Okay, apart from 0. So 0 is not a positive anyway. So you have 3 times 1, that is 3. 3 times 2 is a 6. 3 times 3, 9. 3 times 4 is 12. Okay, 3 by 5 is a 15. Okay, 18. And then we would go to 21, but 21 is beyond the 20. So in this event, the event A will have number of A is, we count them 1, 2, 3, 4, 5, 6. There are 6 elements from that sample space of integers from 1 to 20. Now B is another event defined from the same sample space. Okay, it is the event, the number is a multiple of 4. So let's look at the multiples of 4. Okay, the multiples of 4 are 4 times 1 is 4, 4 by 2 is 8, 4 by 3 is 12, 4 by 4, 16, 4 by 5 is 20. Okay, so the number of B is 1, 2, 3. There are 5. Okay, so next, we look at the probabilities. What is the probability of A and what is the probability of B? Because the first question is asking for probability of A, and the second question is asking for the probability of B complement. Okay, so this is very simple. All right. So we also know that the number of the sample space is 20. When you count those integers from 1 to 20 inclusive, they're gonna be 20. Now, what is the probability of A? Is defined as number of A over number of the sample space. And the A has 6 elements out of 20. You can reduce this fraction into its lowest terms by 2. It's going to be 3 out of 10. Okay? So probability of B is number of B over number of sample space. And there are 5 elements out of 20. So giving us a reduced fraction of 1 out of 4. Okay? But the question is not asking about probability of B. No, they are asking about the probability of B complement. So how do we get the probability of B complement? You know that, but probability of B plus probability of B complement gives us 1. We said the sum of probabilities of complementary events is 1. Okay, so it means that if you want to get the probability of B complement, let me put B complement here so it is seen. Probability of B complement is 1 minus probability of B. Okay, so what will be the probability of B complement? The probability of B complement will be 1 minus 1 over 4, which is equal to 3 out of 4. Okay, so what are the learning points here? The first point that you should understand is the meaning of the word event or the term event. We use it frequently in probability. Then the second term you need to understand is an event. Okay, what is an event? An event is a subset, okay, of the sample space. If your sample space you are looking at maybe the number of students in a classroom, then you could look at the number of boys as one event and number of girls as the other event. But you know, what you are picking must come from the class. So that's what we mean by the event. It is a subset of the sample space. Okay. So the complementary event is the same thing as what is outside that event. Okay. So those terms frequently disturb students when you are discussing probability. But I pledge to make everything clear to you. So we have got this. Let's maybe try to look at some other example, okay, and maybe move on, because this is still part of introduction. We have not yet done serious work. All right, class, let's look at the example 2. Remember, the point we are trying to emphasize is sample space and event. Okay, I'm struggling to ensure that everybody understands the meaning of those two words. What is a sample space and what is an event? That's what I'm struggling to ensure that everybody understands. Okay, so this is a question talking about somebody throwing an ordinary die. Okay, an ordinary die is a one which has 6 faces. Okay, every time you see the word ordinary die, know that they're talking about one with 6 faces. If it's not 6 faces, then they're gonna define for you the number of faces, or they will state for the number of faces on that die. Some die, I have seen some die that have 4 faces. Okay, yeah. So you have to be stable. Okay, I'm sorry, doing something. Okay, but let's continue. So the first question is, a number obtained is a factor of 3. Before we get a factor of 3, let's list the possibility space. Okay, what are the elements of the possibility space? I'll always use the S to stand for sample space. When you throw an ordinary die, each face has an equal chance of showing up. This is a fair die, so you could get a 1 or a 2, a 3, 4, 5, or 6. Okay, those are the possible outcomes, and a set of all possible outcomes is what we call a sample space or a possibility space. Now, from this possibility space, they are defining for us some events. Okay, because there is a lot we can talk about these numbers listed in S. One could say, I want to a number or a face which is more than 7 or something like that. Okay, but here they have defined for us the events. They want us to talk about A. Okay, they want multiple of 3. Okay, so we are defining, let A, okay, be the event. You have to define your events. The event, then you quote a multiple of 3, okay, is obtained. Okay, now we shall talk about A having the elements multiples of 3. I have 3 and 6 from that sample space, because 3 times 1 is 3 and 3 times 2 is a 6. So meaning that the number of A is 2 and the probability of A is 2 out of 6, which is equal to a third. Remember here, the number of the sample space equals to 6. We define probability of A as number of A over number of sample space. Then B, okay, we shall use a B don't always use F for events. If you have more than one event, you have a variety of letters. You have learned the alphabet that has about 26 letters. So let B be the event, okay, a number obtained is less than 7. Okay, so here you discover that all the numbers in S are less than 7. So number of B, without wasting time, will be number of S, which is equal to 6. Okay, meaning that the probability of B is number of B divided by number of S, okay, which is 6 out of 6, and you end up with 1. So the probability of getting B is 1. We are very sure whatever number we get is going to be more than 7. Okay, so C, okay, we shall let C to stand for, okay, be the event, okay, a factor. What's the event? We're talking about an event. Let's define this so well. Okay, a factor of 6 is obtained. Okay, so number of C will be, look at these numbers that we have obtained here. Okay, we want factor of 6. Factors of 6 are 1, 2, 3, and 6. Okay, is the number of C, which is 6, and the probability of C is 6. No. Number of C is 4. I don't know what's happened to me. Number of C equals to 4, and the probability of C is 4 over 6, which is 2 over 3. Okay, so we have everything here that we wanted to, and we have really looked at the events, okay, complementary events, and the sample space. Let me hope you understand what we mean by the complementary event. And let me hope you understand what we mean by sample space and an event. Those two words, mainly sample space and an event, are so important. You know, they should be part of your life as we go ahead with probability. Okay, let's look at something different. Oh, I will apologize where I'm sitting. There is a wind blowing from Texas towards Colorado, that is south to north. So I have really faced a strong interference today. I think you feel the microphone is blown by the wind, and let me hope the audio is clear to you. So, ladies and gentlemen, a very nice book to use here, and it's called A Concise Course. Let me write it for you. Okay, a concise course in advanced level statistics. Okay, it is by J, I think, Rosho, okay, and J Chambers. This book is so important, okay, 3rd or 4th edition, okay, will give you a lot of information what we're talking about, okay. So if you want to follow my lessons and you want to learn, these lessons are free of charge. What you need is data, and then you go to YouTube and you start learning, okay. But don't forget to subscribe and click on the notification bell. The more subscriptions I have, you never know in the future, you could start earning something out of my teaching. But right now it is free. So encourage your friends, okay, your relatives, everyone to subscribe to my channel and we learn mathematics. Let me hope I'm doing something which is useful for the nation. Thank you so much, class. See you in the next lesson, because these are short lessons. I'll not say see you next time. See you in the next lesson. And what is coming ahead is how to illustrate two or more events using Venn diagrams.